Chapter 14, Decision Analysis. In this chapter, we want to talk about how we can make a decision and how we can analyze the decisions. We cover some basic methods to evaluate and make best decisions. So there are a lot of techniques that they are helpful to analyze decisions. For example, we have an expected value method, we have the expected utility theory, analytical, AHP method, and so on. So in this chapter, we cover some of the basic techniques that we need to learn and to analyze the decisions. We have everyone in his or her personal life, they have to make decisions and evaluate the outcome of the decisions. For example, here we have two companies, job offer from two companies, Company A and Company B. Company A is a startup that either could be boom or bust. In Company A, the starting salary is low, but there is a potential that the salary is going to increase rapidly. Also, in Company B, which is an established firm, it is strong in terms of the financial terms, and the starting salary is higher, but the advancement opportunity is slower in Company B. So if you, as a decision maker, which one would you choose? So do you choose Company A or B, or you are not going to pick any of these companies and continue to look for new jobs? So there is nothing wrong with picking each of these companies. It depends all on the attitude of the decision maker. They either can pick Company A or Company B, or they may pursue another companies. So by applying job to other companies. Now, when we talk about the decision problems, we are dealing with several criteria that we need to know. These criteria are alternative criteria and state of the nature. So when we talk about the alternative, is the possible actions that we can take to solve the problem. For example, in the previous example, working for Company A or working for Company B is two possible options, and also we have the third option that we reject both offers and keep looking for a new job. Criteria is the factors that we evaluate decisions. For example, the criteria in the previous example was the salary and the career potential, so how we can progress in the company. The last one is the state of the nature. So how this criteria, this measure, this characteristic of the decision making is about the future events that may happen, and most of the time it is not under the control of the decision maker. For example, Company A may grow or may bust. So this is the two possible case scenario that can happen, but decision maker has no control on them. Another example is that suppose there is an international airport and they want to build a new runway because of the increasing traffic that they have recently. Now there are two possible options, two locations that they can build a runway, location A and B. Also, there is a hotel chain that they want to build a new facility close to the new airport. So the hotel is looking for investment, and they want to make sure that they pick a right location to the invest. in this option, in this decision, we have alternatives that for the hotel chain. They either can buy the land in location A, or they can buy a land at location B, or they can buy at both locations. Or the last option is buying nothing. So they stick to the status quo and they do nothing. So the criteria here is financial gain or financial payoff is a criteria that we evaluate the decisions. And the state of the nature depends on the location of the new airport. Is it in the location A? The airport is built in location A or in location B. So this is a characteristic of this example. Let's say the current purchase price in the land A is $18 million for company, the hotel chain, and in location B is $12 million. And if the airport is built in location A, the future value, the hotel is going to be around 31 million. So, but in location B is going to be 23 million. But if the airport is not built at this location, then the value of the land is going to be 6 million at location A, and the location B is going to be 4 million. So the last row represents if they make a wrong decision, the final value of the sales price is going to be this much. So the question is how we can evaluate this problem, how we can help the hotel chain to make a right decision. There are tools that we can use to make a decision. One of the tools that we have is decision trees. The decision tree uses some specific graphical representation to show the problem graphically. The first one is a decision node. So here at this point we represent the possible alternatives that we have. So the possible alternative for the purchasing the land is 4 options. We either buy alternative A, we buy alternative B, or we buy both, or we do not buy anything. So this is the 4 possible scenarios. So remember, if we buy the alternative A, we have to pay $18 million. So that's the minus $18 as a payoff of this decision. For the B, we have to pay $12 million. So payoff is minus $12 million. If we buy A and B together, we have to pay 18 plus $12 million become $30 million. And if we buy none of this, it is $0 million, zero investment. Once we have this alternative, we have even nodes. Event nodes are represented by the circle. These are the places that the events happen. So state of the natures happen after this node. So we have node 1 at the end of each alternative we have one node. For example, for the node 1, if we buy land A, the airport location could be at location A. The price of the value of the land increases to 31 if the airport is built at location A. If the airport is built at location B, the land is $6. So here you see it's now the same way for location 2. The location 2, if we buy the location B, we have 2 options. The airport is built in location A or built in location B. If built in location A, the value is $4, and if built in location B, the value is $23. The same way for A and B. If we built at location, if we buy both A and B, because we have both cases to consider, basically if the airport is built at location A, is become summation of this 31 and this become 31, and if the airport is built at both location A and at location B, then this $6 million plus $23 million becomes 29. And again, at the last alternative, buy nothing, the payoff is going to be 0 and 0. Now we have to make the final payoff from each branch. So this called the branch. Each of these lines called the branch or the leaf of the decision tree. So if this 31 plus minus 18 millions become $13 million, so this is a benefit that if we buy a land at position A and the airport is built, then this is a benefit that we get $13 million positive. But if we buy a land at position A and then airport is built at location B, the benefit is the difference between these two, which is minus $12 million. The same way for location B, the difference between if we buy land at location B and the airport is built at location A, then the benefit that we get, the payoff that we have, is the difference between this 4 and minus $12 million, which becomes minus $8 million. But if we buy B and the airport is built at 23, then the payoff becomes $11, and the rest for the same. So this is one of the useful tools that we can use in the decision making. The next tools that we have is a payoff matrix. So basically it's exactly the same as the decision tree, except that we represent in the matrix. The matrix is we have the alternatives, so alternative A and B, and none of them. Then depending on the location of the airport, which could be at location A and location B. So if we buy the land at location A and the airport is built at location A, the same way that we had here, the payoff is $13. If airport is built if we buy land at location A and the airport is built at location B, is minus 12. So here minus 12. The same way for the rest of the example. We have, for example, 8 payoffs, and then you can see the same way in the matrix pair. Now we have all of the payoffs. Now the question is how we can evaluate and make decision based on this information, whether we should invest in location A or location B, or maybe both. So we have some rules that they are helpful to make a final decision. There are two main categories to help the decision makers. One of them is a probabilistic, and the other category is non-probabilistic. So the non-probabilistic method, they assume that all of the state of the natures that we have, we cannot assign probability or the likelihood of the occurrence of the states, then we deal them equally. So there are 3 rules that we cover here. The first one is the max-min, and the min-max of regret. So basically you are going to learn how apply this one. So whenever we have this 2 combination, maxi-min or maxi-max, basically first we apply the max for each. Here, for example, for the maxi-max, we apply for each alternative maximum of the payoff, and then we get the maximum of, we pick the alternative that has the maximum. Here we have the maxi-min. So first we pick the minimum payoff of each alternative, and then we pick the one that has a maximum. So maxi-min and maxi-max, they are pretty much similar. The maxi-max represent the optimistic person, maxi-min represent the pessimistic decision maker. Min-max regret also is a similar concept that we will introduce later. None of these rules are the best rules, and basically each of these rules, they may have their own weaknesses that we will cover. So consider the previous example that we had and the payoff matrix. To apply the maximax, we get the maximum of each alternative. So alternative A, B, and none, we get the maximum. So maximum of A is 13, maximum of this is 11, maximum of this 5, and the maximum of this 0. So we have a column on the matrix here, 13, 11, 5, and 0, and 13 is the max of this. So based on the maximax rule, alternative A is the best alternative. Now maximin, based on in the rule of the maximin, we find the minimum rule. So minimum payoff of each alternative. Here minus 12 is a minimum, minus 8 is a minimum, then we have minus 1 and 0. So for alternative A, the minimum is minus 12, for alternative B is minus 8, for alternative A and B is minus 5, and for none is 0. Basically, and then we take the maximum of this, which is alternative none. So that's the solution from this method. Now let's summarize its methods. So in the max, we identify the maximum of the payoff for each alternative, and then we pick the alternative that has the largest maximum payoff. So it has a weakness. The weakness is, for example, consider this example. We have two alternative and two state of the nature. The maximum of the alternative A is 30. The minimum is, the maximum for alternative B is 29. And then we pick this one. If you consider alternative A, decision A, basically alternative A has a payoff of minus 10,000. So if we pick this, there is a high risk of getting minus 10,000. While if we pick alternative B, there is a chance that we get 29. Regardless of the state of the nature. So alternative B is a safe one. So maximax fails to capture this. Maximin is pretty much similar. We pick the minimum payoff of each alternative, then pick the maximum. We pick the alternative that has the maximum of the minimum payoff. So again, it has a minimum weakness. The same way we consider the minimum of this. Minimum of each alternative in this based on the maximin method, and then you see, for example, for alternative A, 28 is a minimum, 29 is a minimum, and then when we pick this one, we are losing the alternative A, and the chance of the getting $1,000 in alternative A. So you can see both of these methods have some shortcomings. The last method that we cover in this part is minimax regret. So regret is another name of this method is an opportunity loss. So basically we compute the possible regret of each alternative under each state of nature. So payoff that can happen, for example, for alternative A is 13. So when we pick alternative A, and the state of the nature happens, basically airport pick alternative A as a location A, then we are getting $13. So there is no regret for picking this location. But let's say if I pick B, then I'm losing $13 and also minus $8. So we add this together, becomes $21. So this is the amount of the regret that we get. The same way, if airport is built in location A and we are picking both, the regret is we investing this much, and then the difference between two is we are losing $8 million in the profit. So 8 is the amount of the regret. So basically in the regret we find the max of this, and then we subtract max minus the payoffs that we have. So here 13 minus 13 becomes 0, 13 minus 8 becomes 21, and so on. So for each column, for each state of the nature, we find max, and then we subtract all of the elements. Now for alternative B, if the airport is built in location B, then when we pick alternative B, location B to purchase, then the regret is 0. So, but if we pick location A, the difference between these two values is $23, and the difference between location A and B and location B is $12. So amount of regret. And then we pick the max of each row. So the max is 23, 21, 12, and 13. And then we pick the minimum of this. So location A and B is the one that minimax regret method suggests. So this method says invest in both locations, buy both locations. So in summary, min-max regret is we compute the possible regret for each alternative under each state of the nature. Then we find the maximum possible regret for each alternative. Then we choose the alternative which has the maximum regret, which has the smallest maximum regret. Again, the min-max has a similar method, similar weakness. So here we have two decisions, two alternative and two state of the nature, and when we apply the regret method, max, min, minimax regret, alternative A is chosen. But when we add a new alternative to this problem, let's say we have new alternative, and this is alternative C, then the story changes and we are picking another one. So we are picking alternative B as a optimal point. So you can see each method has its own weakness. Now in the next session we will cover the probabilistic methods.